Hi, I'm Jonathan Oxer, and this is SuperHouse. A couple of days ago I did a Twitter update saying that I was working on some tiling around the house, and I got a bit of a flippant response coming back on Twitter from someone saying, your tiles don't have enough Arduino. Actually, it was Luke Weston. And someone else responded saying, why don't you turn those tiles into an ambient display? And I thought that was a pretty cool idea. I've been interested in ambient status displays for quite a long time. There's one that really intrigued me I saw a few years ago, which was an umbrella with a handle that would glow a different color depending on the weather report. So if it's going to rain, then the color of the handle would indicate to you that you need to take the umbrella with you. And the idea of an ambient display or status display is that things in your environment around you should provide some information. It's about the environment being smart and giving you things in context, but not in a jarring way. So if you have something that you need to be aware of, but it's not necessarily an emergency, you've got to deal with it right now, you don't necessarily want to be receiving an SMS saying you need to be notified that there is something happening. You might want some kind of a display that just subtly changes in the background so that you'll notice it, but it doesn't intrude into your train of thought. At LinuxConf AU 2012, there was a good talk by Alison Randall about some of her home automation hacks and ambient displays in particular. And so when there was the suggestion last week of turning the tiles in the kitchen into an ambient display, I thought that was a pretty cool idea and a good opportunity to explore that. So what we're doing is using normal ceramic tiles for most of the wall, but we have a strip of feature tiles which are a combination of glass and granite and various things like that. And these glass tiles in particular are transparent glass, and it's been painted from behind, so it looks white, and in normal conditions it just looks like a gloss white finish. But the thing is that if you illuminate that from behind, you can see the illumination come through the tile quite clearly. So that opens up some possibilities. So this device is an Addressable Rgb LED module. Well, you probably can't see it because the thing is just so small. But there is a surface mount RGB LED mounted on a tiny little PCB. No, can't manage to focus on it. And on the back is a constant current driver chip with pulse width modulation. And so what you can do, and it has a simple serial protocol to talk to it, and you can daisy chain them. So what you can do is have a number of these modules in a string, send RGB values for the different LEDs, and you can set individual LEDs to different colors. Very cool. So that's a little module from Freetronics. And what I've done is grabbed 4 of those modules and wired them together. And this is as simple as it comes. It's just from the output of one into the next. So the modules are just stacked side by side, all connected together. And the result of that is, and also this is connected via cable to this, it's a 2010, which is an Arduino compatible board. And I've got a little prototyping shield on the top here. Now there is a sketch loaded into this, or a program loaded into this, that just clocks red, green and blue through the strip and then makes it go blank. So if I push the button, see it goes red, green and blue. I can address them individually, of course. I was just doing them the same color for this purpose. Now if I turn this light off, just so that we don't have so much background, I have some tiles here. These are tiles from the kitchen, and I've stripped off some of the mesh from the back of the plain glass tile. So I'll just sit this on here, and I'll just literally sit the tile straight over the top of the RGB LED module. And now if I hit that again, you can see the red, green and blue glowing straight through the tile. So my intention is to glue the strip of modules onto the back of the tile and have it nice and securely mounted. In fact, if I touch it right up against the tile like this, it'll be even clearer. You can see it come through really clearly there. So when the LEDs are off, you won't be able to tell. It'll just look like another tile on the wall, but then the home automation system will be able to use this to display something. I don't even know what yet. Maybe have it change color based on message status in Skype or number of emails in the queue, or when an order is placed in an e-commerce system or something like that, or flash red when you've missed an appointment or something. Anyway, once it's in there, we've got software control, we can do all sorts of things with it. So the next step, now that I've got it all wired up and tested, I know that it's working fine, is to glue it onto the back of the tile and make a nice strong mount for it. Unfortunately, the image is not, well, the light is not as diffused as I thought it would be. I was expecting that I would just get the whole tile glowing fairly consistently, and I've got pinpoints of light coming through because the RGB LEDs are so intense. I thought about putting an extra diffuser in there, maybe another sheet of paper or something, but I decided that I'd just live with the little spots of light. In some ways it may be more useful because it'll mean that if I have 4 different colours, you can have very clearly distinguished different statuses. So I might choose to use the 4 different LEDs for different purposes. Now I'm not going to want to move this once it's stuck down, so I'll just get it aligned so that it's centered. And now I'll dribble a little bit of this over the edge, the end module, so that it holds in place, and dribble some in between each of them. Now, I'm not sure how this is going to affect diffusion. At the moment there is a bit of light spillover between the different modules, so this may act as a little bit of an optical barrier between them, so that if one of them's turned on it won't affect the others so much. But I have no idea yet. This whole thing is a bit of a suck it and see sort of experiment. Here we go, this is the moment of truth. Feels like the glue is dry. Turn it over. Looks like it's all nicely stuck on and you can't tell. Totally hidden. Let's power it up and see what happens. Stick in the connector. I've got an Arduino back there somewhere. I just need to power that up. And I'll turn that light off. Run the test program. Red, green, blue. Awesome, we have success. Now this is the bad side of doing home automation projects. Crawling around under the floor. Spooky. There's a cable just over there which I need to get up through the floor and then through the wall to run to the back of the tiles. And I'm doing this all in secret because Anne doesn't know that I'm actually doing this. This is a bit of a subterfuge thing, so I want to get it all in place and working before she knows, so that I'll play a bit of a prank on her. I'll illuminate the tile and see if she notices. But I couldn't film it while I was doing it because Anne was just in the other room. She's only a couple of rooms away now, so I still need to be very quiet. But the tile is now in place. It's this one here. And I had to cut a bit out of the back of the plaster to get it on, and I've got to hold it in place with the tape so that it stays back flush with the other tiles. That's right, more than 4 years has passed since I set this up, and I still haven't got around to connecting it. How slack am I? Now what you saw previously was actually meant to be the very first episode of SuperHouse, and it just sat there because it took ages to get around to finishing the kitchen, and then I never hooked it up. But it's all still in there, ready to go. I've just got to see if I can remember how to connect it up. Now some of you may be thinking, he was talking about these addressable RGB modules in the earlier part of the video. Why didn't you just use NeoPixels? Well, I kind of did, but the thing is that when that was filmed, NeoPixels hadn't been invented yet. Well, the term hadn't been, because NeoPixel is a trademark of Adafruit, which they apply to a generally available addressable RGB LED driver module. And that's actually the same chip as what's in these modules. It's just back then, of course, nobody had heard of NeoPixels. Freetronics had these modules available long before Adafruit came out with the term. But it's basically the same thing. In fact, the modules that are installed inside this wall are compatible with the current NeoPixel and Fast LED and other compatible libraries, so we can drive it with the same software. Now back when I put this in place, I was intending to stick one of these down under the floor. It's a Freetronics Ether 10, which is an Arduino with built-in Ethernet. Now, I'm not really quite sure if I'm going to use that or if I'm going to switch to another board, like an ESP8266 based board like this one. This is the Wemos D1 Mini. Now, we need to get power down there, so I need cable. The Ethernet is already in place. We can use that. So the options are to either put in place the Ether 10 and then use wired networking and power over Ethernet to power it, or put in something like a D1 Mini and have this connect to Wi-Fi because it doesn't have onboard Ethernet. So we communicate with it via Wi-Fi and just use the network cable to supply power to it. I haven't decided yet, but I think I'm going to go with the D1 Mini. Whichever one I do, I'm also going to stick down a temperature and humidity sensor because, well, I just want to stick a few sensors around the place. And if I've got a board down under there that's running 24/7 and connected to the network, I want to be able to sense what's going on in the environment. And I'm curious to know what happens with the temperature under the house. How much variation there is between the under-house temperature versus the in-house and, ambient. And I think it would be interesting to plot that data and get different temperature and humidity plots from areas around the house and see, for example, if the values from under the house lag outside and that sort of thing. So I'm going to try connecting one of these up now, and we'll see how this works. My choice comes down to these two boards, something like an Ether 10 from Freetronics or the D1 Mini from Wemos. Now, they both have advantages. The Ether 10 has built-in Ethernet with power over Ethernet support, so that makes it really easy to hook up. Because I've already got Ethernet cable in place, I can just run power down the Ethernet cable and this board will run, which is really cool. I don't have that advantage with the D1 Mini. It requires a regulated 5-volt power supply, so I would need to do something like put a local power supply in place. However, the big advantage of this board in this application is the board is going to be mounted under the floor, and I want to run software updates to it. With the Ether 10, I need to plug in USB in order to push new firmware updates to it, and that would mean either going under the floor to get it out or crawling under there with a laptop to do updates. With the D1 Mini, I can push updates over the air. This is an ESP8266 based board, so I can just compile using the Arduino IDE and push software updates over Wi-Fi. So I think what I'm going to do is go for the D1 Mini, just for this particular application anyway. And to solve the power problem, I've made up this little expansion shield for it. So this fits on top and has a voltage regulator on it and a DC input and screw terminal jack. So I can just put this on here, and now I can simply plug in a power supply and this will power up and away we go. So let's have a look at the overall architecture of how I'm going to do this. We'll put this aside for a moment, grab a piece of paper and draw a diagram. So what we will need is something to provide some coordination for the services. So I'm going to run a Raspberry Pi. In fact, I already have one of these in place, but I'm going to set one up here just for this demonstration. And I'm going to have two pieces of software running on it. OpenHab, which is the home automation controller, and I'm going to have MQTT just for messaging. So I want to be able to, for this demonstration, I'm just going to control it from my phone. So imagine I've got my mobile phone and I've got something like a color picker, and you select a color, and that will be loaded out of OpenHab. So that will be running the OpenHab app and then sending commands to OpenHab. And OpenHab can then send commands to MQTT to publish information on particular topics. So down here what we'll have is the tile with its 4 LEDs, and we want that to subscribe to MQTT. That way when a command is sent to OpenHab to update one of these LEDs, it will be published to the topic in MQTT, the tile will be subscribed to it and we'll see the change in that topic and then we'll update. So let's do that for real. Now right here I have a Raspberry Pi which is already powered up and running, and this is running OpenHab and it has the software on it already. It's got MQTT in place. And over here we have the D1 Mini with the little power thing, and I've also just hacked up a little breakout. And this breakout is in the same format as the pins on the Addressable Rgb LED. So what I'll do is plug that in on top, and I've got a little stack which I can now power up. I've also soldered together another 4 of these modules so that you can see exactly what's going on. I wanted to be able to test this before I put it under the house. So I'll just plug this in here, the same as the one under the house would be plugged in. And just to show you that there's no trickery involved, I'm going to run this off a battery pack. So there are no wires involved here. I'll plug in power, the D1 Mini is powering up, and the sketch that's loaded onto it already simply runs red, green and blue across each of the LEDs, and it then looks for updates on the MQTT topic. Now you can see that one of the LEDs has come on. That's because I was testing it a moment ago and the latest thing published in the topic told this to turn on. And over here we have my mobile phone. There is a group called displays. I'll go into the group and you can see that it's loaded 4 color pickers for LEDs 1, 2, 3 and 4. So if I turn off LED 1, it sends a command, and they're numbered from right to left. So it's actually LED 0, 1, 2, 3. I'll turn all of these off just as a starting point, and then I go to LED 0 as a color picker, and I'll turn up the brightness and set the color over here somewhere. And now we can see that the LED has changed. So I could make that go to red or green or blue. You can see that by touching different parts of the color picker, I can do updates to it. So I'll just turn on the other LEDs, which are all set to different colors. I'll pick the one at the other end and I'll change that to be blue. And so we can see that simply by changing the color pickers on the OpenHab app, it's sending the commands to OpenHab, publishing to MQTT, and then that is being reflected on these LEDs. So we're now ready to put this under the floor. Ultimately, the colors won't be selected by the app. This is just for test purposes so that I can manually control it and see what's going on. What we'll do is have some kind of data source, like a script that checks whether it's bin night or whether someone is home, to do an update to change the LEDs appropriately. But for now, this gives us a great way to test it and make sure that it's all doing what it needs to. So I need to get power to this once it's mounted under the floor. And what I will probably do for that is at one end of the Ethernet cable I'll use a power over Ethernet injector like one of these, and then I'll use a power over Ethernet splitter or extractor down under the floor. So the Ethernet cable will plug in here, and at this end we've got a DC plug which will just bring the power out. So I'll power this down now, pull this out so you can see it, and what will happen is that I'll just use this plugged in to power the sensor that's under the floor. We don't care about the Ethernet in this case because the D1 Mini is going to use Wi-Fi to connect back to the home automation system, and we'll just use the network cable to supply power and nothing else. So now it's time to put this in a box, jump under the floor and put it all in place. Well, it's still spooky under here. This is the cable that we left over 4 years ago. This is now hooked up at the other end in the switchboard, so power should be available on this Ethernet cable. We don't care about the network connection, just the power. So I have here my power over Ethernet extractor, and I can plug this in, and now we should have 12 volts available on this DC jack. Now the other part of this is, over here is the cable that goes up to the tile. Take that off, and this should just plug into my little connector on the Wemos D1 Mini. Now one of the connections is red, which I assume is positive, so I'll put it in this way. And also you can see I've attached a DHT22 humidity and temperature sensor on here because I want to get values from under the house, just out of curiosity. I want to see what it's like under here. So here is a I want to mount it this way, so I'm going to stuff this inside. After I connect up the power, when I plug this in, it should all come to life. Yep, so we've got power on the DHT22, and that's showing power on the sensor as well. So now if I just stuff all of this inside the box, and I've got little slots cut in here, I'll leave the sensor hanging outside because I want to measure the temperature under the house, not the temperature inside the box, which is going to be higher. And then put this cover on, screw it up against this thing. Okay, there we go. I'll just dangle that sensor over the top so that it's up out of the way. Shove that cable up out of harm's way. And now it's time to go and see if we can control those tiles and see if we can get a value off that temperature and humidity sensor. Everything is in place, so now I just need to test it. Let's try with the OpenHab app. Pretty cool. Now I can drive those with whatever data source I like. I just need to figure out what it's going to be. See you next time.